These are the teacher notes for the mole ratio lab. I want to talk a little bit about the setup and a little bit about the results you should expect. So for the setup, any bin will do that's can take the graduated cylinder submerged. I wouldn't make it too large and too shallow of water. You will need to be able to raise up the graduated cylinder so that you have enough room to get the tubing underneath and up into. And you don't want the graduated cylinder resting on the tubing because that could pinch off some of the gas that's trying to flow through the tubing. Make sure that your container is clean before you get started. If you have any residual chemicals in there, that may interact with the chemical reaction and may affect the amount of gas that's being produced. The technique for filling up the graduated cylinder and then inverting it and then submerging it is tricky for students. And so I usually have my students practice it a few times. Naturally, they're going to collect some air bubbles up there. And if the air bubble is large enough, I just tell them, measure the volume of the air bubble and then subtract it off of the gas volume that you read later on in the trial. But once they do a few of them, they get pretty skilled at it, and the amount of air bubbles is minimal, and I don't worry about measuring the volume of those. I usually tape down the tubing so that when I am shaking the flask to get all of the particles to interact, the tubing isn't, going wild and pulling out of the graduated cylinder. You want to have a length of tubing that's good so that you have some mobility with your flask and you're not, again, pulling the tubing out of the graduated cylinder. And then finally, we have our trials over here. So the results of the trials should be exactly this, where we have our first two trials having excess acid and the last two trials having excess base. And then the one in the middle should be green with no reactants left over at the end. So then when we're graphing this at the end with volume of CO2 on the y-axis and grams of baking soda on the x-axis, we can see that we have a sharp linear increase at the beginning and then it plateaus off starting at this point. So it's up and then plateaus off on the graph. And then students are using that graph and the data discussion in the classroom to determine which ratio is best for the reaction. Best meaning we produce the most CO2 with little to no leftovers remaining at the end of the experiment. So that concludes the teacher notes. Good luck.